Right now, without thinking about it, you are breathing, your chest rises, your chest falls. It happens thousands of times a day, every day, for your entire life. And you have never once stopped to wonder if you're doing it correctly. But here is the strange part. Most of you are not. Your nose is not just a passageway, it is a processing system. When air enters through your nose, it passes through curved structures that filter particles, humidify the air, and warm it to near body temperature. By the time it reaches your lungs, it has been cleaned and conditioned. Your mouth does none of that. Air in through the mouth arrives cold, dry, and unfiltered. But there is something even more important that most people have never heard of. Your nose produces nitric oxide. Your sinus cavities generate this gas in significant quantities. And when you breathe through your nose, it travels into your lungs and dilates your blood vessels. That dramatically improves the transfer of oxygen into your bloodstream. Mouth breathing delivers no nitric oxide at all. A study by researchers at the Karolinska Institute confirmed that nasal breathing can increase oxygen uptake by up to 18% compared to mouth breathing. 18%. Just by changing which hole in your face you use. So why do so many people breathe through their mouth? The answer goes back further than you might expect. Your ancient ancestors chewed constantly. Tough roots, raw meat, fibrous seeds that required real grinding force. That chewing built broad, wide jaws and large nasal passages. But your food today is soft, processed, pre-broken down. Over generations, narrower jaws became more common, smaller palates, crowded teeth, airways that restrict, and so the default shifted. Millions of people now breathe through their mouth without ever realizing it. The effects compound at night. Studies suggest that 30 to 50% of adults breathe through their mouth during sleep, the hours when your body is supposed to be repairing itself, and the symptoms are not subtle. Waking up exhausted despite a full night, a dry mouth, a sore throat, snoring. In more serious cases, sleep apnea, which now affects an estimated 1 billion people worldwide. But there is a deeper problem even beyond sleep. It is about what your breathing tells your nervous system. Your body has two modes, fight or flight and rest and digest. Fast, shallow breathing tells your nervous system that a threat is near. It primes the stress response. And if you breathe that way constantly, as millions of people do without realizing it, your nervous system stays in a low-level state of emergency, not full panic, but a persistent background hum of stress that never fully switches off. Here's the counterintuitive part. It is not low oxygen that makes you feel the urge to breathe. It is high carbon dioxide. And carbon dioxide is not simply a waste product. It plays a critical role in whether your red blood cells actually release the oxygen they are carrying to your tissues. Without adequate carbon dioxide, oxygen binds too tightly to hemoglobin and cannot reach the cells that need it. This is the Bohr effect, first described by Danish physiologist Christian Bohr in 1904, which means that overbreathing, taking too many breaths, and exhaling too much carbon dioxide can paradoxically reduce the oxygen your cells receive. Breathing more does not always mean your body gets more. It can mean it gets less. The optimal breathing rate for an adult at rest has been measured in multiple studies at around 6 breaths per minute. The average adult breathes 12 to 20 times per minute, twice as fast, sometimes more. And 6 breaths per minute feels impossibly slow at first. Inhale for 5 seconds, exhale for 5 seconds. Try it right now. That sensation of not getting enough air is almost entirely the feeling of elevated carbon dioxide, not actual oxygen deprivation. Your blood oxygen is fine, but your body has been trained to interpret that signal as panic. The work of Patrick McKeown, founder of the Buteyko Breathing Center, shows that this sensitivity can be retrained over weeks. Your body learns to tolerate higher carbon dioxide, it learns to breathe less, and paradoxically, it functions better. Andrew Huberman, a neuroscientist at Stanford University, has described the physiological sigh as one of the fastest ways to calm your nervous system in real time. A double inhale through the nose, followed by a long exhale through the mouth. The double inhale pops open collapsed air sacs in the lungs. The long exhale clears the built-up carbon dioxide. Your heart rate drops. The stress response quiets. It takes about 30 seconds. Your breath is one of the only physiological systems you can consciously control that directly changes brain activity. When you slow it down, you slow neural oscillations that send synchronizing signals to your hippocampus and prefrontal cortex. Your memory sharpens, your thinking clears, your emotional regulation improves. You are not just breathing, you are tuning your brain. So here you are, right now, the same body that has been breathing since the moment you were born, doing something it has done hundreds of millions of times. And almost certainly doing it a little wrong, not catastrophically, not wrong enough to stop functioning, but wrong in small ways that have stacked up quietly for years. The answer is not complicated. Close your mouth. Slow it down. Breathe through your nose. That urge you felt just now to exhale and try, it was not a coincidence. It was your nervous system still doing exactly what it was designed to do, waiting patiently for you to pay attention. For